So are you ready? Are you looking up? Right, so we said the length of that was 6 units. Looking up. So to get a square number, we multiply 6 by 6. And what do we get? 36 is the area, isn't it, of that piece of card. So, hello, looking up. If we're given the area, so let's say if we're given a square number, and we want to find, if we're asked to get the square root, basically what we're doing is we're finding the length of the side. We're working backwards. So a square number, 6 by 6, gives us the area. But if we're given a number like 36, which is the area of the square, we know it's a square number, don't we, straight away? Right, if we are asked to get the square root of 36, what are we doing? We're getting the length of? Okay, you can use that in the calculator. The square root sign on the calculator, 36, and you get 6. But what are you actually getting? You're getting, it's telling you what is the length of the side of the square. Do you understand that? Right. So if we use a calculator, give me a square number first of all.
81.
81. Fair enough. So we need to go 3, 3, 3. 3, 3, 3. Alright, so there's, you give me 81, which is an area. That's a square, that's an area. So when I get the square root of 81, what the calculator is giving me is the number 9. And that means 9 is the length of one side of the square. Well, they're all the lengths, all the sides are 9 in length. Right. What happens if you give me a number that's not a square number? So let's say 74. What's the square number below 74? 64, isn't it? 88, 64. So 1, 2, 3, 4, 5, 6, 7, 8 and a bit. 8 and a bit. So I'm not sure what it is. So it's 1, 2, 3, 4, 6, 7, 8 and a bit. Right, so if you use your calculator right now, yeah, so we're not sure. 74 is not a square number, so you can't figure it out. You can't figure out what the length of that side is in your head. So we go on with the calculator and you go square root sign there and you type in 74 equals. Press SD. Alright, so the length of this side is 8.60232526.7, and the length of this side here is the same, 8.60232526.7. So when I multiply that by that, I will get the area. Okay, each one of those sides is 8.02325267. Do you understand what a square root is?
Yeah.
It's getting the length of the side of the square. Okay. Now while we're at it, we will do a couple of examples from that exercise. At the end of that exercise. Right. For example, on question 16, we have a question like this. So just look up using complete the sum using whole numbers. So actually this is not a square number, we're just filling in a box, alright? Right, what whole number is just lower than the square root of 5? We don't know what the square root of 5 is. The square root of 5 is not a square number, so we get square root of 5 equals, and press SD on the calculator, 2.236, right, 2.236, that's enough. So we'll write that. Okay, so what number what whole number is less than 2.236? 2 is less than, that's the next whole number, less than. What's the next whole number greater than 2.236? 3. Okay? So that's how you answer questions in question 16. Alright? Okay, an example of on page 13, question 17. The square root of 169. Well, we can do that. Square root 1, use your calculator, it says, is 13. So that's a sum that you need to remember for the rest of your life. Alright? Square root of 169. What was the square root of 144? 12. That's another one, square root, that you need to remember for the rest of your life. Alright, what's the square root? Another one you need to remember. Square root of 225 equals 15. That's another one you need to remember forever. Square root, and another example, square root of 441. Yeah. 441 is 21. Alright. Right, there's another example, and etc. Now example of question 18. 18. 4 to the power of n is equal to 16.
2.
Now, yeah, exactly. We have to find out what that number is. Yeah. So basically, what we do is we write down, well, how many 4s does it take to get 16, first of all? 4 by 4 is equal to 16. So we figure out how many 4s we need to multiply, and then we write it like that. So it's 4 to the power of 2. So n was equal to 2, isn't it? N is equal to 2. That's how you do that sum from start to finish. Is that difficult, that one?
No.
Right. We'll do another one. 2 to the power of n is equal to 8. So first of all, how many 2's do we need to multiply to get to 8?
3.
2 by 2 by 2 is equal to 8. So that's 2 to the power of 3 is equal to 8. So what's n equal to? N was equal to, see there? 3. Okay. Question 19, you just have to fill out the boxes. So we'll do one example. Copy and complete. So you have, first of all, you have to complete the diagram. So they have 10 is equal to 10 to the 1. 100 is equal to 10. You have to write down 10 by 10 is equal to 10 squared, isn't it? And then 1,000 is equal to 10 by 10 by 10 is equal to 10 cubed. And then 10,000 is the next one. How many tens? 10 to the 4. Right. And then it describes, number 1, what is the pattern? What pattern do you see? What pattern do you see here on the left hand side? Looking up. What pattern do you see? 10, 100, 1,000, 10,000? Adding a 0 on the left hand side. What pattern do you see over on the right hand side? 1, 2, 3, 4. What do you notice about 10 to the 1? Or 10 here. How many zeros does it have? 10 to the, it has 1 0. How many zeros does 100 have? 10 to the 2. It has 2 zeros. How many zeros does 1,000 have?
3.
It has 3. 10 to the 3. How many zeros does 10,000 have?
4.
Right, so if we skip, if we skip a few and write down a million,
6.
10 to the
Power 6.
Power of 6. What is 100 million?
9. 8. 7. 6.
8. There's 8 zeros. I skipped. 8. 1,000 million? 9.
It's a billion.
What's a million million?
A billion.
Oh no, 12. 12.
Okay, 12. Right.
Is it 12?